Okay, so in this numerical test, we're going to do this three numericals. Let's go to 12.9, which is on page 226. Okay, so example 12.9, which is on textbook page 226. So there, figure is given to us. So let us draw that first directly from the textbook. Something like this is given to us. There's a resistance here. Draw along with me, R1, and then below it another one is placed, which is R2. So below and above means these two are parallel, and the wire continues and comes down here. There is an ammeter means to measure current. Then comes down, then it goes here, and here there is a resistance again, which is mentioned as R4, and then above it there is another resistance which is mentioned as R3. Below this there is another resistance again, R5. So they again above each other, so that is parallel. This set is in parallel, this set is in parallel. Of course, this set is not in parallel with this, but this set separate R1 and R2 are in parallel. Then these three sets, R3 to R5, are in parallel. Then there is a switch here to switch on and off. Then there is a battery here. This is the shorter line, so this is negative. Shorter line and longer line is positive. Then we put a dash, right? So 1, 2, 3, 4 are there. So maybe we can start from here just for space. For the sake of space, small, long, then dash, short and long again, then another cell, dash, then short and long again. So this is battery, means this is the longer line positive, this side is the negative. Right, so, or you can put it outside also if you want. Inside also no harm. And this is the positive terminal. Then we know that as the switch is on, always current flow from not negative to positive. That is wrong. Positive to negative. So I will come out here. We'll go through this, and when they come, some current go here, some current go here, different amount, and when they recombine here, it will become I again, and it flows through this ammeter, and the ammeter will tell us how much current is flowing. Like that it flows. Okay, and we have to calculate, so let us just do A. A is, go to question, calculate the total resistance in the circuit. So here, to calculate, we'll do two steps here. This set, in this class we'll do this example only, next class we'll do this too. Okay, so here, these two sets let us take. Now, clearly the R1 is above R2, or we can say R2 is below R1. So above or below means these two are in parallel. So let us find the total of these two first. So let us write here, since they're in parallel, RP1 be the total resistance of R1 equal to, it's given in the question there, R1 is 10. R1 equal to 10 ohms, so this is 10 ohms. And R2 equal to, textbook again, 40 ohms, so this is 40 ohms. So these two, which are 10 and 40 ohms, are in parallel. The question did not tell us, but we can figure it out because one above another is parallel arrangement. So if it's parallel, then we know these are the formulas we keep in mind in electricity so far. The first formula is here, I think I is equal to current is charge by time. Second one, potential difference is work done divided by charge transfer. Third one, the Ohm's law, V is equal to I into R. The fourth one is, I think, parallel or series, whatever you like to write first. Series resistances, then total RS is R1 plus R2, etc. Fifth one, if the resistances are in parallel like the one we did just now, formula is not total of parallel but reciprocal of the total. 1 by Rp equal to first one plus second one, etc. depending on how many resistances are mentioned in the question, right? So there are only two here and they are clearly parallel, so we will use this parallel formula. So total is Rp1, means we have to use in line with that formula. 1 by Rp1 will be equal to 1 by, the first one is R1 plus 1 by R2. Okay, so here that implies 1 by Rp1 will be equal to R1 is 1 by 10 ohms plus 1 by, here is 40 ohms. So as we continue here, that it will give you 1 by Rp1 is equal to LCM is 40 ohms. Because we know 10 and 40 LCM is 40. Then take the first denominator, 10 4s are 40 LCM. So that 4 into 1 numerator, multiply the numerator, 4 1s are 4. Plus similarly, 40 1s are 40. So 1 1s are will be 1. Just a matter of doing carefully. 1 by Rp1 therefore will be 4 plus 1 is 5 divided by 40 ohms. So 5 8s are 40 means 1 is left here. 5 1s are 5. So if we cross multiply down and up or up and down, up to you. Rp1 into 1 is Rp1. Cross multiply means one set up and down, then put equal. Then the next set of down and up or up and down. So 1 8s are 8. And ohms is here. So the total of these two is 8. Okay, so let us just keep this one as equation number 1. Similarly, let's do for these 3 sets here. So similarly, let Rp2 be the total resistance of the, okay, total resistance of the R3. Let's go to textbook. R3 value is 30 ohms. Then R4 is 20 ohms, and R5 equal to 60 ohms. Clearly they are in parallel again. Yes, we can see here, see, one above the other. So we have to use this formula again. So their total, you can come here, their total, reciprocal of the total, Rp2, 1 by Rp2 is equal to 1 by, first one, sorry, R3 plus 1 by R4 plus 1 by R5, right? Quite simple, right? So 1 by Rp2 will be 1 by, and R3 here is 30, so we write here 30 ohms plus 1 by, here this one 20 ohms plus 1 by 5 is here 60 ohms, so we write that. So these two together total we find separate, these two total we found out the total, and we will go to the next step to find the whole total. Okay, so as we go on from here, still there is space, so let us just do 1 by Rp2 equal to 30, 20 and 60 LCM is 32s are 60, so the biggest one 60 among the three is a multiple of both these two smaller ones. So in such a case, the biggest one becomes the LCM, right? So 32s are, meaning 32s are 60, 23s are 60, which means the biggest one is a multiple of both the smaller one. Then the biggest one becomes the LCM. We know that, right? So 32s are 60, 2 1s are 2. So next, similarly, I won't explain anymore. 23s are 60, 3 1s are 3. Then here 61, 1 1s are 1. So it's just a matter of doing patiently. Rp2 equal to this 2 plus 3 plus 1 is 6 divided by 60 ohms. So 6 1s are 6, 6 10. So cross multiply, you will get Rp1 into Rp2 into 1 is Rp2. Then this one 10 into 1 is 10, and then here ohms. So the total of the next 3 set, these 3 combined total is 10, these 2 combined total is 8 ohms. So we'll have to proceed to the next step. So let us do here. Now, since you got these two together as single total here, we can redraw a figure. So now the figure above the first one, that means may be redrawn, okay, redrawn as below. Now redrawing like this is not necessary, but it really helps us to understand. That's why we're redrawing it. So these two combined has become a single value 8. So we're going to represent these two combined. Or the rest of the figure we will not change. So here the rest of the figure is same. This is positive, then short line, then long line, negative, long line. So 1, 2, 3, and one more long line. And then here I think we can put it instead of going down. So here short line and long line. So 1, 2, 3, and 4. So here we go like this. Then this part is also same, so we can just draw here, switch, and go here. Then okay, let us redraw in that space that is bigger here. So here the figure may be redrawn, means remember here, let's just put here RP1 equal to 8 ohms represented in equation 1, and then we can have space now. Then RP2 there, okay, let's see. So the same figure we're drawing, okay, so here long line, positive, short 1, long line, short line 2, long line, short line 3, long line, short line 4, minus 1, 2, 3, 4. And we go here. Then here, these two has recombined to give the value single R. So we'll just represent RP1. Now this is RP1 equal to 8 ohms. This way 2 has been calculated to have single value total this much, to make understand, okay. Then here switch is there. Then after switches, this 3 has been found total is this much. So the 3 has become now a single. And the value is RP2 equal to 10 ohms. I hope you're getting it. Redrawing like this helps us to understand what we're doing, okay. So let us say this is RP2. Let's put it here, RP2, 10 ohms. This is equation number 2. The rest is fine, so you can just rub it out. Now the figure has become like this, and the rest will not change. This is an ammeter to measure current. Now we forgot to put here, but it's okay. This side is positive coming like this, so this side is the positive terminal of the ammeter, negative terminal. Similarly positive and negative, except for this 3 total now single, this 2 total, this 3 total single. The rest of the figure are same. So when you switch on the current, the same amount of current is flowing throughout the circuit. I see. So we now redrawn as below means now. So now let R be the total resistance of the RP1 now and RP2. Clearly now, here see here, this is not in parallel anymore, okay, see here, it is going this way. Now the ending part of 8 ohms is here, RP1, and that ending part is joined to the beginning part of RP2. That is series. See here, if it is above and below, then see here the beginning and ending of the same, first one R1 and R2, beginning of R1 is A and ending point of the resistance is B. Same here, R2 also a beginning point here, ending point. But this is not so here. the ending point is somewhere here. Then the ending point is joined to the beginning point of RP2. And this is series now, so we have to write in series. And then this is connected to a battery. See, positive, negative. That is why here beginning and ending are same for these two. But here battery is here. See, then the beginning part of RP1, ending point of RP1 is connected to beginning part of RP2. Ending are different. That means it's series. So in series. So if it is in series, therefore we have to use series formula. The total is R is equal to RP1 plus RP2. Not reciprocal but direct sum. Okay, so here RP1 is already 8 ohms plus RP2 is 10 ohms, as we get this one by using equations 1 and 2. In 1 we will get RP1 value, and in 2 we get RP2 value 10. So total resistance of the whole circuit is 18 ohms. This is the total resistance of the whole circuit. So A answer is done. So we may put this one as equation number 3. And right here, that is A. So now let us go to B. B is, what do we need to find? Let us see. The total current in the circuit. So I, this current flowing, question mark, total current flowing in the circuit. So obviously we have to use Ohm's law, V equal to I into R. So we need to find I. So we have to know what is R and V. So R is already there. See here, total resistance of the whole system. So here we need V equal to I into R. So V is there already. Go back to question. Voltage is, look at the question. 2 volts means this is the voltage. 12 volt is the total potential difference. Or we can just write total also if you want, total potential difference. So we need V. We found we need R. So R is also there. R is equal to here 18 ohms, since using equation number 3, right? So if you know V and R, we can easily find I by using Ohm's law. So you write here using Ohm's law. V equal to I into R. Just write like that. The next step, this is already done, so I'll just write it out here. This is also done. That implies here C, V. Then you bring this R down, because if we shift it, numerator will go denominator, and we want to find I. V is here 12 volts, as we have seen here, divided by R just now from equation number 3, 18 ohms. So both are in SI system, so current SI unit is ampere, meaning volt by ohms is ampere. So 6 2s are 12, 6 3s are 18. So if you divide 2 by 3, then 3 6s are 18, 2 in hand 0, 3 6s are 18, 2 in hand 0, 3 6s are 18. Like that you can go to third place usually if you want. Usually we go to third place. So 0.6, sorry, I'm going to get here 0.666. So that gives you 0. Third place is 5 or more than 5, that will become 7. So this is your answer for current. This is equation number 4, let us say. So finally you can write your answer. Final answer once if you want. A, total resistance. So total resistance of the whole circuit, which is denoted by R, is equal to here 18 ohms, since using equation 3. And then B answer is, go to text if you want to write the language, total current. So total current flowing in the circuit, we have taken that to be I, and just now 0.67 ampere, and we can write here since using equation number 4. So this is done. 12.9 example 1 and 2 we'll do in the next class, after which you can take the test. Okay.